So good day, Sir Aldrin. This is my laboratory exam for the midterms. So these are the questions. So the first question is, create a circuit and ASM program to toggle every 500 millisecond all the bits of port B and port C continuously using 0xAA and 0x55. So the program that I did was this. So what I did was, since it says that I need the 0xAA and 0x55, so I assigned it to the register 16 and register 17, and then I looped it, which is here, and I complemented it in order for me to toggle the register R16 and R17. So in order to like appreciate it more, here is the solution that I did. So it says that every 500 milliseconds. So I am assuming that it is the time delay already. So the time delay is 500 milliseconds or 0.5 seconds. So since the oscillator frequency of 80 megahertz is 4 megahertz, so we will substitute it to this IC and then or the instruction cycle IC multiplied by 1 over 4 megahertz is equal to 0.5 seconds, which is the time delay. And what you will get from that is the amount of cycle or the instruction cycle, which is in this case is 2 million cycles. So once you got that instruction cycle, you will use this delay program in order for you to calculate the iteration, the number of iteration. So as you can see, I have LDI, 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 and decrement and branch not equal. So LDI, 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 decrement, branch not equal. This is that. And then for the next one, decrement, branch not equal, decrement, branch not equal, and then decrement, branch not equal, decrement, branch not equal. So this specific equation is for the 3 loops. Since I need 3 loops here in order for me to have that kind of cycles, like in order for me to have this many cycles, I need 3 loops. So I used 3 loops. So after that, you will have 6m plus 3m plus 3n, and then you will just add that. You will have 12m, and then you will divide both sides by 12, and you will have this answer right here. So you will have 166,666.6667. So that is approximately 167,000 iteration, and then you will get the 3 factors of that. So 4 times 167 times 250, and then you will get the hexadecimal equivalent of those, and you will input it here in this delay code, delay values here. So 0x04, 0x87, 0x8. So that's what I did in my computation part. So here you will just import that specific code right here. So let's import it here in this circuit that I made. So and then we will run it. There you go. As you can see, there is a delay between the toggling of the switches. So there you go. So if you just like focus here, you will notice that it switches from on and off like 2 times in 1 second. So on, off, on, there you go. It is toggling like 2 times per second. So there you go, that's the first one. And then the second one is this. It says create a circuit and ASM program to toggle every 300 milliseconds all the bits of port B and port C continuously using the complement instruction. So that is this one. So I used 0xFF values to appreciate it more, and then I complemented it, R16. And then this is the delay equation, the same with the number 1, and this is the delay computation. So the same method, I used 12n and then divided both sides by 12. Here you go. And then I got 100,000 iteration, and then the 3 values that I needed for the loop. There you go. Since 100 times 100 times 10 is 100,000, so those are the 3 values that I needed. And then these 3 values, I will convert them to hexadecimal, and then I will I inputted it right here in this delay code. So in order for us to see that, let us like stop this and then import that code. There it is. That's the number 2, and then there you go. And then let's run it. There you go. As you can see, there you go. It is faster than the number 1 because this has delay time of 300 milliseconds only, and the other one has a delay time of 0.5 seconds, right? So as you can see, and if you focus right here, you will notice that it is blinking 3 times in 1 second, like here in this part right here, in the lower left corner. You will see that it is blinking 3 times in 1 second. So there you go. So for the third one, we have this. Create a circuit and ASM program to toggle port B.2 and port B.5 every 200 milliseconds. So I use this code. And I only use 2 loops here, not 3, because I will show you later the delay computation. But the main thought was that you will assign, since this is 0x24, you will assign here 0x04 and 0x20 in order for you to like toggle the specific bit using the exclusive OR instruction in AVR. So without further ado, let's proceed to the time delay computation. So the time delay computation is this. So we only needed 400,000 cycles. So we can do that with only 2 loops, right? So I only used like LDI, document match not equal, so that only amounts to 5n, and then the preceding ones which amounts to 3n. So 5n plus 3n is 8n, divide both sides by 8. We will get 50,000 iteration, and then we will get the 2 values of the iterations in the 2 loops. So we have 200 times 250, which is equivalent to 50,000, and then we will convert those 2 values to hexadecimal, and then we will input it right here, 0xC8 and 0xF8. So to simulate that, we have this. So let's import that number 3. And then right there. So then when you input this, as you can see, it is fast, very fast, because it should be toggling itself 10 times in 1 second. So if you just focus right here in this lower left, you will see that it is turning on and off like very, very fast. Like in 1 second, it will turn off 5 times on and 5 times off. Like if you just focus here, 5 times on and 5 times off. Since it is like 100 milliseconds, right? So there you go. So since the delay time is 100 milliseconds, so let's just stop it right there. Since we'll now go on to the number 4, which is create a circuit and ASM program to toggle every 1000 milliseconds. So that this is 1 second. So the time delay computation is this. So we will use the same method as we did with the first number 1, number 2, and you know. So we use 3 loops here since we will have 4 billion cycles. So yeah, we used 3 loops, and then we got here 333,900, which is the approximate value since we only got 333.3333 iterations. So that is the approximate value, and we will have these values right here, which corresponds to the 3 loops that we will need to have, right? That we will need to have the value on. So we have 212, 225, and 7. And when you multiply all of those, you will have 333,900. And then you will get the hexadecimal value of those numbers. And then you will input it here in this code, which is this. This is the code for the number 4. As you can see, the port has been changed because in the problem it says that it is port A.0, not port point B. So I changed the port to port point A point N. There you go. And the bit placement 2, and then the value, right? So there you go. Let's just build this and then save it. There you go. And now let's simulate it. First, simulate. Let's import this file. There you go. Number 4. There you go. And then let's simulate it. It should be really slow though, like really slow. Oh, it should be right here, right? Sorry. So wait a minute, I'll just fix it. Now there you go. It's been fixed. So let's try this again, shall we? So there you go. As you can see, the first and the last one is like toggling on and off every second. So 8, 9, 10, 11, 12, 13, 14, 15. There you go. But as you can see, it is toggling itself. So there you go. And for the last one, we will have this one right here. This 5. Create a circuit and ASM program to toggle alternately using yeah, there you go. Every 250 milliseconds. So port B.2. So this is the delay time computation of that. So we have 0.25 seconds. So we will only have 1 million cycles. And in this 1 million seconds, we will need 3 loops. So we used 12n, and we divide both sides by 12. We will have 83,333.33333, which is approximately 83,500. And we will get the 3 values that are needed for the loops. There you go. And then these 3 loops, you will this value of the 3 loops, you will get the equivalent in hexadecimal, and you will input that in this code. You go 0xfa, 0x02, 0xa7. So let's just let's like import it here in this. There you go, and then we will have this number 5 right here. There you go. And now there you go. Since it has 0.25 second delay time or time delay, it should be toggling itself 4 times per second. So if you just focus on this lower left corner, you will notice that it's toggling itself 4 times in every second. So 1, 2, 1, 2, 3, 4. On off, 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 on off. There you go, 4 times, right? There you go. So well, that will be all. And these are my comments, but I will pass this alongside with my video. So yeah, I hope that answered all of the questions that are in the laboratory exam. Thank you, sir, and have a nice day.